All right, let's talk about combinatorics. And look, I get it. That word might bring back some not-so-fun memories of math class. But we're going to forget all about that. Because in business and finance, combinatorics isn't just theory. It's a critical skill. It's the art of counting your possibilities so you can make much, much smarter decisions. To show you what I mean, let's start with a question straight out of the world of finance. Picture this. You're an analyst. You've done your homework and found 20 really promising tech stocks. Your plan? Build a portfolio with just 5 of them. Seems simple enough, right? But how many different 5-stock portfolios could you actually create? Just take a quick guess. The answer is 15,504. Yeah, that is a huge number of potential portfolios from what seemed like a pretty small list of stocks. And this isn't just a fun fact. It shows a real danger in finance. The risk of only looking at a few options you already know and completely ignoring thousands of others that might be way better. And that right there is the whole point. Combinatorics isn't about instantly finding the one single best answer. It's about mapping out the entire landscape of your choices first. It's step 1. You have to understand the full scope of what's possible before you can even begin to pick a winner. So, how in the world do we start counting all these possibilities? Well, we begin with the most fundamental tool in our entire decision-making toolkit, the multiplication principle. It's super simple, incredibly powerful, and it's basically the engine behind everything else we're about to cover. The rule itself is just beautifully straightforward. If you have m ways of doing one thing and n ways of doing another thing, the total number of ways to do both is just m times n, and you can keep doing this for as many steps as you have. Think about ordering dinner at a restaurant. Let's say you've got 4 appetizer choices, 6 choices for the main course, and 3 for dessert. How many different 3-course meals could you create? You just multiply them. 4 times 6 times 3. That gives you 72 completely unique dinner combinations. It's really that intuitive. Okay, but what happens when your choices aren't just a simple sequence? This is where we hit the single most important question in all of combinatorics. It's the question you have to ask yourself every single time. Does the order matter? Because your answer is going to tell you exactly which tool you need to grab next. So, if the answer is yes, order is absolutely crucial, then you're dealing with a permutation. A permutation is all about arrangement, about sequence. Think of it like a race. Finishing first, second, or third are all very different outcomes. The position matters. Let's put this in a business context. You're a venture capitalist, you've got 9 great startups to look at, but you can only fund 3 of them. And you're not just picking 3, you're ranking them. Your number 1 pick gets the most money, number 2 gets less, and so on. Here, the order is everything. Using the permutation formula, we find there are 504 different ways you could rank your top 3. But what if the order doesn't matter? Well, now you're talking about a combination. A combination is simply a group. You're just selecting items, and it doesn't matter who was picked first or last. All that matters is who makes it into the final group. That's why the formula is a little different. It has an extra part that gets rid of all the duplicate arrangements of the same people. Let's go back to the office. Say you need to build a 3-person project team from your department of 20 employees. Does it matter if you pick Alice, then Bob, then Carol? Or if you pick Carol, then Alice, then Bob? Nope, it's the exact same team. So this is a combination. And the math tells us there are 1,140 possible teams you could put together. So here's the bottom line. Before you do anything, you have to ask yourself, does the order matter? If you're ranking, arranging, or assigning specific roles, it's a permutation. If you're just picking a group, a committee, a team, a portfolio, it's a combination. Getting this one question right is seriously half the battle. Okay, now that we've got the fundamentals down, let's level up. We're going to look at some more specialized tools you'll need for more complex business problems, like allocating resources or distributing capital. First up, multinomial coefficients. This sounds complicated, but the idea is simple. You use this when you need to take one big set of things and split it into several smaller, distinct groups of specific sizes. Think about operations management. You have 10 officers you need to assign to 3 shifts, 5 for the day shift, 2 for the evening, and 3 for nights. The formula tells you there are 2,520 different ways to arrange those crews. Next, we have a technique with a fantastic name, stars and bars. This is your secret weapon anytime you need to distribute a bunch of identical items, like dollars or units of inventory, into a number of distinct buckets or categories. It's absolutely perfect for solving financial allocation problems. And the way it works is actually pretty cool. First, you take your identical items. Let's say they're $1,000 investment units, and you represent each one with a star. Just line them all up. Then, if you want to split that money into, say, 4 different funds, you only need 3 dividers, or bars. You place those bars anywhere in the line of stars. The number of stars in each section is the amount that goes into each fund. And just like that, a complicated finance problem becomes a simple arrangement problem. So let's apply this. You've got $20,000 to invest, broken into $1,000 units across 4 different funds. This is a classic stars and bars problem. You have 20 stars, your money, and you need 3 bars to create those 4 funds. What's the result? There are 1,771 different ways to allocate that capital. That's 1,771 unique investment strategies. We've covered a ton of ground here, right? From the most basic counting all the way to these advanced distribution methods. So let's pull it all together into one practical, easy-to-use toolkit that you can use to tackle any counting problem that comes your way. And here it is, your roadmap. When you're faced with a problem, just walk through this guide. Is it a series of separate choices, one after the other? Multiplication rule. Are you arranging things where order is key? Permutation. Just picking a group where order doesn't matter? Combination. Splitting a big set into smaller defined groups? That's a multinomial coefficient. And distributing identical things into different buckets? That's stars and bars. It's that simple. And really, that's the big takeaway here. Understanding the true scope of your choices is a massive strategic advantage. So the next time you're looking at a problem, whether it's about allocating resources, segmenting a market, or building a portfolio, remember that deep down, it's a counting problem. The only question left is, which tool from your new toolkit are you going to use to solve it?